Alright, this lesson is about solving systems of linear equations, and I'm going to go over two ways, either using substitution or using addition. This is in chapter 4 of your book. If you're following along, I'm kind of starting around 289-ish. Remember, you can look at your book if you want through My Math Lab. There's an ebook there. Alright, so what you're doing when you're doing these systems of linear equations is you're trying to figure out the answer to those lines or those equations. So for example, we have our grid and we have a line that kind of goes like this, and we have another line that goes like this, and we're trying to find that point. So sometimes it's not easy, or you don't have the means to graph it to find the answer. So this is the other option that you would do. Alright, so let's start. They give us two equations. And they ask us to use the substitution method. So the substitution method is that you're going to take one of them and plug it into the other. Now, to be able to do this, you either need it to say y equals or x equals, so that you can plug it into the x or the y. Well, this one they already gave us in a good form. They already told us what the y equals. So on my second equation, instead of writing y, I'm going to write what it equals up here. So I just substituted this y for this equation. Then I'm going to solve it, which means I'm going to distribute first. Simplify it. Subtract 3 from both sides. So we get the answer of 3 for our x. Well, we need to know what our x and y are. So we need to know our coordinate, both coordinates. So if we know what x is, we can go back to one of the original equations and plug it in, and we can find what our y is. So I just took this 3, plugged it in here, and then when I solve this, I get -4. So the nice thing about these is you can plug them back in to make sure they work, because we do make silly mistakes sometimes, and you know, a mistake in the first part will make a mistake in the second part. So it's nice to plug them back in and see if it works. So this is just going to be my check. I'm going to first plug in my y, then plug in my x. That one checks out. Now they both need to work to check out for it to be a true answer. So 4 times 3 minus 3 times -4, and that should equal 24. This is 12. So we do get 24 equals 24. So that's the nice thing about these, is you can check yourself, especially if you're taking a test. It doesn't take, it took me maybe not even a minute to check my work. Alright, let me do another one. Alright, so I'm using the substitution method still. So that means one of these needs to be either x equals or y equals. And I always try to look at them and see which one would require the least amount of work. So in this case, I'm looking at this one. It has a plain old x. These all have coefficients with them. So I'm going to pick on this guy. I'm going to make this one x equals. So that means I would bring this over. So when I did that, now I have the form I want, and I'll just plug it in. Distribute. Simplify. Add 15 to both sides. And I get 4. Now I need to plug that back into either one of the equations. I generally try to plug it back into the one that I didn't manipulate. So like I'll use the other one. Oops, this one's still an X. But I don't think it really matters. So I get X is 5 and Y is 4. And we can do a quick check. 5 times 5 minus 4 times 4 should equal 9. So that one checks. Then I'll check my other one. 5 minus 2 times 4 equals -3. 5 minus 8 equals -3, and that one checks. So my answer is 5 and 4. If they ask you to write it as a ordered pair, remember your X goes first, your Y goes second. Alright. Let's do one more. Let's do two more. So I have y plus 1 equals 5x plus 1, y equals 5x minus 1. So it says solve the equation using the substitution method. So I already got one that I can plug in. So I plugged this into here. If I simplify this, and I can see we're going to have a problem. So if I subtract 5x from both sides, I have nothing left on that side. And this is a not true statement. 0 does not equal 5. When this happens, there is no solution, which means these lines never cross. So whenever you cancel out all your x's and what's left isn't true, there's no solution. So let's do the other problem that happens. I shouldn't say problem. So if I use substitution, I'm going to plug in that into my y, simplify it. Okay, this time my x's do cancel out, and I'm left with 6 equals 6. So this is a true statement. 6 does equal to 6. So when this happens, it has infinite solutions, which means it could be any real number. No matter what I put in here, it will always be a true statement. So when that happens, that means it's a line that is on the same line. So we have a coordinate system, we have a line, and then the second line is exactly the same spot as the first line. On our other one, we have a line, and since we have no solution, which means they never touch, then it's going to be a parallel line. Alright, so let's move on to the substitution method, the addition method, which is on page 297. Alright, so let me give you an example. Alright, so where's our two lines? We're trying to figure out where they meet. Alright, so with the addition method, you're trying to eliminate one of your variables. So that means cancel out. So I'm going to look at what I have. So this one's kind of nice for us. If I was to add these, if I was to add these two equations, the y's would cancel out. So that's what I'm going to do. We're going to add these two. So when I have here's two x's, my y's cancel out, and then 4 plus 6 is 10. So that is your whole goal of the addition method, is to eliminate one of the variables. So in this case, x is 5. Then I can go back to my original equation, plug it in to get my y. So we get 5 and -1. And again, you can plug these in just to make sure that you did it correctly. So if they ask for ordered pair, I should keep writing that just in case that's what they ask for. Alright, so sometimes they're nice. I mean, these were already opposites of each other, but that doesn't always happen. And I'll use this next one as an example. We like when they're nice and simple like that, but that's not the real world. Alright, so there's my two equations. We need to use the addition method or the elimination method, whatever you want to call it. So I'm looking at my variables, and I could cancel these out if they were both, one was 6, one was -6, but that means I'd have to times this one and times this one. But I can look at my y's, and the least I have to do is the one I'm going to pick. So if this was a -5, this is a +5, these would cancel out. So what you do is you find that number and you multiply the whole thing by it. So I'm not going to touch the second equation, we're going to leave it the same. But my top one I'm going to make 5 times bigger. So 5 times 3, 5 times -y, 5 times 11. So don't forget to multiply everything by 5. Now when I do the addition, my y's are gone. And this comes out to 4. And then I'll go back to one of the original equations and plug my 4 in. And I get 1. So my answer to this system of equations is 4 and 1. So always when you're trying to figure out which one to eliminate, try to do the one that causes you to not have to do so much work. I could have chosen the x in this case, and we could have made them opposites of each other, but I would have to multiply 1 by 2 and 1 by -3, or 1 by -2 and 1 by 3, and we don't want to have to do that much work, so we try to pick the less steps. Let's do another one. So if I'm using the addition method, I like the way these are looking. So if I times this one by 4, then I will have opposite y's. Right, so the top equation I times by 4, the bottom equation I'm not touching. If I add them to, this one's gone. This was 114. Which comes out to 6. And then I'm going to go back and plug it back in. I try to plug it back into the one that I didn't manipulate. It doesn't really matter, but I like to touch both of them, so that is why I do that. So I get 6 and 2 as my answer. And again, take the time to check them. A minute to know if you're right or wrong, especially when you're taking a test. Alright, so let's make it a little bit harder. So solve this using the addition method. So I can get rid of my x's or y's. I can choose either one. I know I could make this one a -9, and I could make this one a +8 pretty easy, so it doesn't matter which one you do. I think I'm just going to do -3. So if you chose to make this one times 4, you will still get the same answer at the end. Okay, so our new equation on the top. And then I didn't touch the bottom one. So you don't want to touch both of them unless you have to. Sometimes you do have to though. That's canceled. And 168. 168 divided by 14 is 12. So I get y is 12. Then I'm going to plug it back into an equation. And I get 8. So my answer is 8 and 12. Alright, and let's just do one that's a little bit harder, which you'll see every so often. Alright, so this one's a little bit tougher because there's not something I can do to the one equation to be able to get rid of the variables. So when this happens, just pick the x or the y and try to make them opposites of each other. So these I could make one positive 6 and one negative 6, or I can make one of these 35 and one of these negative 35. I like smaller numbers, so I'm going to choose the x. So I think I want to make this one a positive 6 and this one a negative 6. So remember, your goal is to have opposites so that they'll cancel out. So my new equation for the top is that. My bottom is that. And now I can add them. Canceled out. And this one is 85/31s, so they don't always come out pretty. And then I'm going to plug this back into one of the equations. To get my y. So this one's not pretty at all. I multiplied the numerators, kept my denominators. I'm going to move this over. And we have to have common denominators. So if I make this a 31, I have to times that by 31. Ran out of space. So I have 2x equals 68/31s. Then I would divide both by 2. 68/31 times 1/2 is 68/62, which can be reduced to 34/31s. So that one's quite ugly. So that was my x. 34/31, and my y was 85/31. Because we have fractions, I'm going to go ahead and plug it back into my original just to make sure it works. So I'm going to check. Let me rewrite my two equations. So we're going to plug those in. So we have our x as this, and our y as this. And they should equal -17. So this is 68/31s, take away 85 times times 7, 595 31s, and that's supposed to equal negative 17. 595 is negative 527 31s, and if I divide that out, I get negative 17. So that side checked. And then we'll check our other ones. 3 times 34 31s plus 5 times 85 31s, and we want that one to equal positive 17. And 102 31s, 425 31 25. I get 527 31s, and that does equal positive 17. So sometimes they don't come out pretty, but just be patient with them. And I always check the ones that come out fractions because it's easy to make mistakes with fractions. And then just like when we do the addition, we can have infinite solutions also. And let me give you an example. Alright, so we want to make these opposites, so I like the way this one's looking. I can times this one by 2. It didn't touch the bottom one. When I subtract these, gone, gone, so there's nothing on that side, and there's nothing on that side. So if everything doesn't cancel out, just remember what is left needs to be true. Well, 0 does equal 0, so this is infinite solutions. And then let's do one where you can see how they don't leave the prettiest leftovers. Alright, so if I times this one by negative 3, then my bottom one I didn't touch. So when I add these, this is gone, so there's nothing there, and then this side's left with 1. Well, 0 does not equal 1, so there is no solution. So that means these are parallel lines. Alright, so just pay attention to those two situations. You will see those. Alright, if you have any questions, please let me know.